let's take a couple of minutes to refactor this code. I've been mentioning that for a while now, and we have some basic features in. We might as well clean the code up before we continue. So refactoring is just taking code that works and cleaning it up, just making it more sensible, more easier to maintain, easier to read, following the code standard, but without breaking it. So we have these comments to guide us a little bit of where our goal is. And so what I'm going to do is start with pre-declaring these functions. We want a setup, an update, a render, and a teardown. So let's start with those. Void setup, void teardown, void update, void render. I am unsure, like maybe we want setup to return a flag if it fails, or maybe we wanted to throw an exception, and then we have to talk about what exceptions are and how to deal with them. I feel that exceptions are a good thing, but I'm not sure we want to spend the entire video talking about error management, so maybe we do that in the classroom. For now, I'm just going to leave it as a void function, and then, we'll see where we go from there. But these are the declarations. Let's bring them down for definitions. Can leave our check inputs here. Actually, now that I see these to-dos, I might also add what I want to do here is call a function to deal with this type of event. This is the key down event, so I probably want something like on key down. My event handlers are generally called on something because it's when an event happens. So on key down, on key up, those are functions I want to have. And I probably want this to take an SDL keyboard event. Or, no, actually I don't. A keyboard event is a bit large. The keyboard event is going to have a lot of different data in it. And all I want is actually a key code. So I want to know what key was pressed. I'm not sure if it's called SDL key code. This is just a comment for now, but this is probably the signature I'm looking at later on. So when a key is pressed down, we call another function on key down to deal with whatever key was being pressed. That way our core event checking loop here doesn't grow too large. Maybe also I want to refactor this to a switch statement, but we'll do that later. So setup is, I was going to say it's easy enough, but obviously it's not, because we're going to have to deal with error checking here at some point. But we open that body up, and I'm going to bring down the stuff here that is needed to set SDL up. We want init. Going to bring that down to setup. It returns here, so that's need to be commented out for now, because it's a void function right now. Then we want to create a window. We want to create the renderer. That's the end of the initialization. Once we have the renderer, we're good. So immediately we notice a couple of issues here. The window and the renderer. Well, the window doesn't actually need to, well, it needs to live after this function. So it needs to be outside of the scope of this function. No, it doesn't, because SDL creates it somewhere else. It will be out of scope. We only have the address to the window. We don't have to worry about it. But no, because we have to clean up. That's right. We have to be able to call destroy at the end of our main. And so we have to have access to that pointer. And that means we have to move this out of the function and make it a global thing available to the rest of the application. We also notice that a lot of these are returning error codes right now. So instead of breaking all of my current code, let's set up return an int, return results, and then return 0 if everything went well, because that's what we've been doing so far. We notice that there are several values here that does not exist in this function, so those are going to have to become global as well. Let's start with, let's see, we go back up. We change the declaration to int return for setup. These values are needed by setup, so I'm going to make them global, bring them up here, put the constants on top. So app name is my game, the screen width and screen height are declared like this. I'm going to rename them. So right click, rename. There's a function to do this safely, right? So let's call it screen width. This is stupid. Maybe I should call it window width. World width. This is a virtual thing. Let's call it screen width, whatever. Rename. Screen height. We can bring the background color up as well. And now I notice, of course, that our render draw color call wants to save its return value. So I'm going to create an integer there. The renderer does not exist here because it's currently being declared and defined in setup. So we need to bring both of the window and the renderer out into the global scope. So I'm going to copy this, bring it up. I'll put that under is running. Because this is now a member, or sorry, a global, I'm going to call it underscore renderer. And the other one is STL window pointer underscore window. So now we can go through here. That's underscore renderer. That's underscore renderer. That's underscore renderer and underscore window for the destruction. Down into the setup function again. We don't have to create the STL pointer. We use underscore window. We use underscore renderer. So we reuse the ones we created, right? Pass in the correct window. Notice here that the rename function obviously went through and changed them down here as well, which is what we wanted. So far, so good. Let's see. We have error checking. It's important that we check after every function call because STL get error only gives us the last error. So we can't do this at the end of the function. So here is still a bunch of redundancies, but we can deal with that later. Right now, we have gotten it out of main, so that's neat. If setup is called, we are calling STL init. We're calling create window, setting up our underscore window. It sets up create renderer into our underscore renderer, and it returns 0 if everything went well. So I can close that up. That's a feature just so we don't have to scroll too much. If I go back up here, I can uncomment this, and we can do something like if setup is not 0, return 1. Something went wrong with initialization. Not the most elegant solution, but we'll look at other solutions in a bit. So now this is in the wrong place, right? We have to call setup first thing we do. Set render draw color should probably happen every frame. This is the background color, but we are clearing the buffer every frame. So if we draw something on top of that, we're going to have to bring this in. So let me just put it in here. And that actually tells us that we might as well implement render. So we have the function render. Let me bring that up. And then I take all my render calls. We set the draw color, we clear, and then we present. I see here we're presenting using the wrong name. It should be underscore renderer. We can bring all of that rendering code. Cut. Move it into the render function. We open the function body, paste that code. This definitely does not need to return anything. Whether the delay should be inside render or inside the main loop, it's a debatable thing. I'm going to keep it in the while loop though, just to show when we're looking at this loop that it's going to spend some time going around. It won't spin at 100%. Teardown is easy. We can call it here. This is all the teardown we have. So if we open this function instead, let me close render there. We open the teardown function with a new body. We paste these in. One thing we have to be careful about is now that the initialization of these pointers is happening somewhere else, we have to make sure that they are valid before we try using them. So previously, we could be sure that if any of them were null, we would immediately exit main. That's still true, but because we are defensive programmers, we want to make sure we don't make any null pointer dereferences. We're going to check here in teardown that these pointers exist before we try to remove them. So we're going to do if renderer is not the null pointer. And we also have to keep track of the order of initialization. So we want to make sure that we destroy them in the opposite order that they were created. If window is not the null pointer, we want to destroy that pointer. And lastly, we call SDL quit. So far, so good. This means that we can call teardown from anywhere without risking a crash from accessing these pointers. I'm pretty sure that SDL has a check that calling destroy on a null pointer is a safe operation, but we can't be sure. And assumption is the mother of all fuck-ups, so we double check. We make sure that we're not trying to destroy a null pointer. This also reminds me that we should initialize those pointers if we are not doing it. So up here, we're declaring SDL renderer pointer. It's undefined at the moment. It doesn't have a value. So let's make sure we set them to the null pointer. This way we know that when teardown gets called, whether they have been initialized or not somewhere, sorry, reinitialized somewhere, they will have the null pointer that we expect. Sorry, that doesn't make sense, but you know what I'm saying. Always initialize your values. Lastly, we have the update function, which is currently empty. That's fine. We can use that to get some animation going. So I'm just going to open that body. And let's see, setup is pretty much done. Well, it's not done at all, actually. We're going to have to do some proper error management here. I'm going to vote for exceptions because that's cleaner than having a bunch of returns. It allows us to do basically all error checking in one place. But at the moment, this is good. So I'm just going to move these out of the way so we don't have to scroll past them all the time. So I cut that, move them to, say, below the input checking. Right? Teardown is good. Setup is good. We can put them out of our mind for a while. Render is doing very little. It sets a color, it clears the buffer, and then it presents the buffer. So we're just drawing a solid screen still. Let's compile and see if this all works. See what errors we created. No, it worked. Oh, that's amazing. That almost never happens. I'm impressed. Let's see how much time I've wasted. That's 12 minutes. Do we want to try to put maybe a square on the screen? If I do something like const int, let's call it ball width. And let's put that at, I don't know, 15 pixels. So what we can do is, let's say we go down to render. No, you know what? This is good enough. We have cleaned up the code slightly. Our main is now shorter. We have the core game loop in place in that we check inputs, we update, we render, wait a little bit so we don't burn our CPU out, and then we do it all over again. This is the core game loop. We have a setup, we have our teardown. So in the next video, let's see how we can, say, draw something, maybe move it around. We can talk about coordinates and, well, basic rectangles. The update is not going to be used much, is it? No, it doesn't matter. It's a void function, does nothing. The compiler will optimize that away. We don't have to worry. All right, see you in the next video. You know, if I can figure out how to stop this.